spectacle to see. Typically, when we're talking about blockchain networks, these numbers like TPS are given as, the measure of how fast or how good a blockchain is. Now, there's a couple of things to say. Number one is that TPS can be measured in a number of ways. Usually, companies choose the way to measure it that makes them have the highest score. Now, another thing to mention is that TPS, it means one thing, which is, you do a very high throughput of transactions, but that might mean that the transaction that you submit might be confirmed in 1 second, or it might be confirmed in 5 seconds, right? Sometimes if you optimize for throughput, rather than kind of what we call latency or time to finality, then that can have implications for your users. So it doesn't create necessarily the best user experience. I think an important thing to mention as well is that when companies do these kind of controlled tests, you can optimize, you can kind of cheat basically by sticking all the servers in locations that have very high connections between each other, high-speed connections. So you can basically create a kind of system where you generate a figure like 100,000 TPS, which doesn't really reflect how the blockchain network using your software works in reality, right? So I think what we can say is, if you look at, say, the production, in actual real life, these blockchain networks working to run applications and serve users, say has the second highest TPS, transactions per second, in the industry there, as we saw, second to Solana. Solana has a kind of other layer where there's some sort of voting or consensus thing that happens, which really boosts that number. But Say has a high TPS, but also this time to finality thing is really important as well, right? Because that time to finality means how fast is your transaction included in a block, and then how fast can you say, right, that transaction is final, it's done. So if we want to do a trade, right, and you want to buy something from me, or you want to swap some tokens, then you want to find out that the trade has gone through, right? And so if you want to buy something from me and then you send a transaction and then you have to wait 10 minutes to see, right, the transaction's failed because it's not been included in a block, or you haven't had enough gas fees or something, versus, now we can have, 390 milliseconds finality. So you're not going to notice as a human, right? It's going to be in instant. Either the transaction's gone through or it hasn't, so then you can try it again. That's going to be a significant, they're significantly different experiences, right? So as a user, when you use an app, and as a developer, if you're building apps that focus on these sorts of things, where maybe we're doing DeFi and we're taking a trade somewhere, maybe we're buying something from somewhere, borrowing something from somewhere else, and then it's all coming through into your phone as a user, right? You don't want to be sitting there waiting 10 minutes, 20 minutes for this stuff to happen with no transparency. You want to see what's happening when you want things, when you decide you want to do things, when you decide you want to take an action, you want to see the outcome of that quickly. So it's, that time to finality becomes really important, because it means that developers can build applications where these things happen faster, and ultimately that results in this user experience for you as a user where it's much faster. So time to finality is really important, especially when we're talking about trading, financial apps, and DeFi, these other sorts of things where if there's counterparties and they're trading, time lag can really be dangerous. It can be risky. It can cost you value, right? If you're doing these sorts of complex transaction-based interactions. So yeah, to summarize, TPS is a number that companies will burnish. They'll try and exaggerate, inflate it as much as possible, because people think, well, a higher TPS blockchain is faster.